Welcome back, lesson 24, contingency tables. That means we are very close to being finished with the class because lesson 25 is going to be the last one. So, the idea of a contingency table is somebody's age and whether or not they have a job, is there a relationship between those two? So these are the younger people, these are slightly older people, and then they were asked whether or not they're employed. So they weren't asked, is it a full-time job, part-time job, just yes or no? Do you have a job? So you can see in here with the younger people, 12 of them said yes, but a lot more of them said no. When it came to the people between ages 30 and 42, there's a lot of them that said yes and much fewer that said no. So probably there is a relationship between age and whether or not people are employed. Now to find out. Okay, so for one thing, with the claim, you don't even write numbers, you just write it in words. So the claim is that employment and age are independent. So in other words, the claim is saying that whether or not somebody has a job and their age have nothing to do with each other. I'm not saying that's true, I'm just saying that's the claim. And if you watch the lesson 23 video, the graph is the same. And it's also a right tail. So this is going to be a right tail only test. And then we're going to look up the critical value in a moment. Now to input this information in the calculator, we don't actually use lists. We use something different, which is called a matrix. So if you look at right here on the calculator, mine's blue, so not the little x to the -1, but the blue part right there says matrix. So you need to go to, first I need to turn the calculator on, and then you go to second matrix. And I've used the matrices before, so this has some numbers in there. If you haven't used it before, it would probably just be blank. Perfectly fine. Next, you move over to edit and just leave the cursor on number 1 and hit enter. And right now it's asking me what size matrix do you have? Well, the size first goes rows, so this has 2 rows and it has 2 columns. So this is a 2 by 2 matrix. So just put 2, enter, 2, enter. And these numbers in here are left over from some other problem that I did. So what you do once you have the 2 by 2 matrix, and if you've never used it before, it probably filled zeros in here. So then you just start typing the numbers. So 12, enter, 34, enter, 41, enter, 11, enter. Okay, now we have the information in the calculator. Now we're ready to do the test. So once you have this information in the calculator, then just go to Stat, Tests, and then go down to letter C, the chi-squared test. That is where I like to use my red pen and write down that I'm using letter C, the chi-squared test. Okay, so back to the calculator. So when you do the chi-squared test, this should always say matrix A, and the expected should always say matrix B. So you don't have to make matrix B. All you have to do is put its name right there, and the matrix A should be right there. So let's say that somebody was messing with your calculator and it's blank. And then right now, once it's blank, it won't let me go anywhere. It's like, no, you have to put the matrix A name right here. Okay, so you go back to matrix over here on the left, put second matrix, And with the cursor on A, just hit enter. And then it will put the name A in there. And if somebody had messed up this one for the expected values, then just go second matrix, go to letter B, and just put the letter B in there. So you definitely do have to get it from the matrix because it has to have that little box around it saying that's matrix A and that's matrix B. All right, then go to calculate. And there's actually two things that we need from this. One is that's the test statistic, chi-squared equals the 27.359. And then the calculator is nice enough to tell us the degrees of freedom equals 1. So let me write down that information. So the degrees of freedom equals 1. I'll need that in a moment to find the critical value. And then for the test statistic, chi-squared equals the 27.359. All right, one last thing we need to do on this example, and that is look up the critical value. And if you watched lesson 23, I said we actually have to use a paper chart because it's not on the calculator. So it's a right tail only, so we're only going to use the right side of this little chart. And then, oh, I forgot to write, we're using 95% level of confidence, which means that this side is 5% or 0.05 on the right. So then you look on the part that is the right side, which you might want to label, this is the left tail, this is the right tail. So we only use the right tail, and it's 0.05, and then the calculator said degrees of freedom is 1, which means it's this first row right here. And when you get to the column that has 0.05, that says the critical value is 3.841. So then go to my critical value, 3.841. So anything that goes past 3.841 is considered unusual. This is very unusual. 27.359 goes way past it, which means that the claim is false. So what that's saying is this word independent is false. So if you just take off the in, that means they are dependent. So employment and age are dependent. So whether or not somebody has a job seems to have something to do with their age. Okay, so then let's look at one more example, and I'll just switch to a fresh piece of paper here. So test for independence between, now it's going to be gender and whether or not they have graduated from college. And so basically you just write the claim in words. So claim, gender, and I'll just abbreviate it college degree rather than having to say all of those words, and college degree are independent. So basically it's that claim right there. So whether or not somebody's graduated from college, does that depend on their gender? And as you can see here, for the females, it's 16 yes and 19 no. And for the males, it's 18 versus 17. So that's not a big difference. Like on this previous example that I just did, you can see for the younger people saying yes, it's small, but then this is big. And when you go to the older people, this is big, but then that's small. So that's why we got reject on this first one. With this one, it's not a very big difference at all. So we go through the same steps. There's the claim. and this is going to be the critical value. Again, we're going to use 95% level of confidence, and that means that this right tail is 0.05. And because the table is the same size as the last one, that means that degrees of freedom is going to equal 1 again. And you'll see when we do the calculator, it's going to agree and say degrees of freedom is 1. So now we need to enter this information. So go to the matrix, make sure that's on the screen, the matrix. So go second matrix, and then over to edit. And if it's already set as a 2 by 2, then you can just go down until you get to the numbers and type in the new numbers. So 16, and when you hit enter, it goes across 19, and then the next row 18 and 17. All right, now that the information is entered in the matrix, then go to stat, tests, and go down to the chi-squared test, so that's letter C. It's a great time to use my red pen. So letter C, the chi-squared test. All right, when I do that, it's gonna again say matrix, this should be matrix A and matrix B. The good thing is once you've set that up, it's not gonna change. So you don't have to mess with it. You can just go down to calculate. And sure enough, it does say degrees of freedom is 1. So that's good news. And then it says that the test statistic is a 0.229. So for the test statistic, chi-squared equals a 0.229. And then I need to use the piece of paper to look up the critical value, and that is 0.05 on the right, and degrees of freedom is 1. So it's this very first one right here, 3.841. So the critical value is 3.841. And in order to prove something, the test statistic has to go past this. Well, this graph starts with the 0 on the left, and this number was so small, it's basically way down here. It's not even close to rejecting. So we cannot say that college degree and gender have anything to do with each other. So we did not actually prove anything here. All right, that's the end of lesson 24.